Sometimes you just gotta have a banana for scale. Stay tuned. Hi, this is Kevin with Inventamark, and today I'm going to be talking about how to make gears. Right here I have an extruder that I use. It's the Cyborg extruder. I got it off of Thingiverse. I'll have the link to that in the description of the video. Anyway, this is the one that I use. It's works pretty good. The filament goes through here. It's got a spindle here for the hub bolt, and I just use actually a 5/16 bolt that I have, because I couldn't find any metric bolts around here, so I used that, but it works just the same. Anyway, I'll show you how you can make your own custom gears to fit whatever you need, depending on how strong you want to have the motor be compared to the output of the filament extrusion. So anyway, let's get started here. So what I like to do is go into top-down view. I already have the motor there, and it's centered on the one spot, and I already have it centered over there, but I'll need to recenter it here. The first thing I like to do is basically create the bolt that I need. It's going to be 8 by 8. Really doesn't matter how long it is at this point, because we're not really making the bolt, we're just making a simulation of it. So I kind of put it where I think the center is. Then I duplicate that and just make a bigger one that goes around, that fits up, and you got to kind of match it up to this other thing here. Kind of line that up as best as you can. And get it lined up there, and then you Shift S, cursor to selected, and then select the other one. Selected the cursor, that gets it right in the middle. Turn on my screencast keys. Keep forgetting to do that. Okay, so now we have the center point for both of the gears that we want to make. And for the gears, what I like to do is you can kind of like pick a ratio that you want to have the gears to be. And you have it 2 to 3, 1 to 2, 11 to 35, or 4 to 34, whatever you want them to be. And when you have the gears, the best way to do this I found is whatever your gear ratio that you want it to be, so you add the gears together. So let's make this how about 4 to 9 ratio. So we're going to have a 4 to 9 ratio. So one of them is going to be turn 4 times, the other one will turn 9 times, so it equals the same. So those added together equal 13. And so what we need to do, we need to measure this distance from here to here, and whatever that distance is going to be, then we can get the information we need from that to make the gears. So here up on top, let's go back, this one is located at, we're on the y-axis, so over here on y, we're at 18.51, and this is located at negative 23. And there we go. Negative 23. Let's get the calculator out. And 18.51 plus 23. So the distance between them is 41.51. And so to calculate out what we need to divide that by 13 up here that we got, the ratio. So the distance from here to here divided by the ratio that we want. which is 13, equals 3.19. And so that's the key number that we want to remember to use when we're making this. So the 4 gear is going to be the smaller one, so that's going to be the one that we want to put here. So the cursor is selected here. And so if you don't have the gear option here, you need to go into Settings, User Preferences, Add Mesh, and there's a couple of different options here. The Add Mesh Extra Objects, and Bolt Factory is good too. You can use that. So you add both of those, hit Save Settings, go ahead and close that, and you push Shift A. Excuse me. And you have the option of gears down here. And you go to Gear. Oh, undo that. So gotta move the cursor over there first. So add gear. And then we have the options box down here for the properties. And number of teeth, we'll look at that in a little bit. But for the radius is what we want. So we go back to what we had before. So we want to take the 4, multiply it by that 3.19. So we take 4 times 3.19. Gives us 12.76. So that's going to be the radius of this first gear. And so if you look, well, actually, can't see the gear. It's inside of the motor there. I'll pull it back up when we get this done. But we can see it from here. And the base is basically just this. Just want to make it smaller than the outside of the gear. And the addendum, this is the inside of the gear where the teeth are, how much that goes in. I usually just go to about 1, typically works for most things. And let's try 1.25. I usually try to get those to match the same always. And as far as number of teeth go, that all depends on how fine you want to have the teeth. I usually do what looks good. There's no real calculation that I have for that. Let's see, 20 teeth. If it's that big around, let's try 16. That'd probably be good. So we got 16 teeth there. And you can actually make the change the pressure angle and change the outside of the tooth there. But that all depends on what the pitch of the teeth you have, basically. And so I think we're done with that gear. Oh wait, no we're not. We need to change the width of it. And usually a good width is probably about 6 millimeters. So that gives you kind of an idea of how big it is. It's 6 millimeters by that big around. Because whenever you move the gear, just like with anything else, it disappears. And so let's go ahead and move the cursor to that. And add the other gear. And so it brings back the same exact size gear that you were just working on. So you can actually use that if you want to change things pretty quick, because it'll keep all the settings that you have here. And so we got to take 3.19 times 9 is 28.71. So the radius is 28.71. Yeah, that's right. and so the gear comes out to the right size. But for the number of teeth, we want to kind of have this be a multiple. So 16 divided by 4, that's what this ratio was, would be 4. So you want to have 4 times 9. So you can actually just do the math in here, which would be 36 teeth. And that makes the teeth line up exactly. The ratio goes into the same way, so whatever your teeth you have on the first one that you do, the same ratio applies to the other one. So it was basically 4 times 4 is 16, and 4 times 9 is 36. So then we get the correct gear ratio there. I can change the base down a little bit. And so it looks like they line up pretty good here. And we really don't need to do anything else to the gear. Rotate Z just to double check that they line up good. So it looks like they mesh together well. And the right number of teeth are displaying. And that's pretty much all you really need for making the gears. To modify them to work properly, I like to go into edit mode. I'll click around the ring here, which will let me. There we go. And hit F, and that creates a face on there. So when you go back to that solid mode, it shows it solid there. So we have 2 solid gears now. So what I like to do is, typically it's a 5mm for most stepper motors that 3D printers use, is the 5mm cylinder. And wrong one, I gotta keep forgetting to move the cursor. And so I usually do a little bit bigger. And you want to have bigger than the gear. Okay, so when I did 6 for the width, I doubled it for some reason. You can actually just change it back to 6. But if you make them skewed or anything like that with the twisted edge, then it completely changes it. Anyway, so that's bigger than that. And you can do a boolean. And gotta remember what that part was called. Cylinder 2. Make sure it applied. Then you can delete the cylinder. And over here, you can actually just use the one that we made previously. That's cylinder 1. Apply. And so there's that. And with this was a specific undo that. With this specific extruder, it uses a Hex Bolt Head. And to create that, you just create a cylinder. Actually, move the cursor over here first. Create a cylinder. And so it creates a small one. You want to make this 13. So you size that up. That cylinder 2 now. So then you have the bolt pattern in there, and it'll hold it just right. And that will basically make the gears. For this one, what you would probably want to do is make something that where you can put a screw in there to tighten it down. Oh, wrong one. Okay, so we got that. You just want to have it smaller than the teeth. So I got that. And you can actually do the cylinder thing after you get everything done. I'm going to have to do it again because I already did it. And I actually have to make it a different size because sometimes the boolean doesn't work if you do the same exact size. Let's make it a little bit bigger, but we'll do that later. And for the bolts, what I like to do is I actually like to just make a bolt. That's what the bolt factory option was. So if you zoom in, it makes them really small. The type that I use is the Allen cap bolts with the preset M3. And it creates the bolt there. And the only thing we really need to change is the shank length, or the, actually not the shank length, the thread length. I usually use 10mm whenever I'm doing anything like that. But let's go ahead and make it a 20mm just in case the thing I made, I don't know exactly the radius of the shape I just made. And so it's still really small. So after you make the bolt, you just need to multiply it by 10. And it creates it pretty much the right size. And so you can do that. Then I like to create another one. This time just go to M3 and then change it to nut. And it's right there. And then enlarge it by 10 again. Rotate it. Oop. And kind of put it where you want it to be. But I had to give enough plastic for the screw to push against both ways, so you kind of want it in the middle. And kind of want to line it up there. I usually rotate it about 30 degrees on the y-axis. So we got that, and then click on there, shift, cursor to selected, shift A, add cylinder, on the hexagon, and then rotate X 90. Then we can kind of size it up just a little bit bigger than the bolt or the nut. And then we can size it this way just a little bit bigger. And so it's basically the right size that we want it. Now we can, from the edit mode, grab those top parts, move it up. And so we have that sticking out there. duplicate that. You can be more precise. If this was centered on here, it'd be better, because then you could do plus and negative on both sides of one line, but I'm just kind of eyeballing it here. So join those together with Alt-J, joins two objects together. And here I'm going to put another cylinder. It's going to be for the screw hole, as you do 3.25. Every printer is different though. Mine prints out 3.25 about just right for the M3 bolts, because it'll leave a little bit of grip left in there. So now we have all the objects that we need. So we actually don't need these in here at all. These were just for visual reference, because we're not using those. We're using basic simple objects to subtract from this. So we'll go Boolean difference. This was cylinder 2 for these two that I joined together. And so you can see in there, if you look, it's got the cutouts there. Apply. So it's got the bolt cutouts. This is cylinder 3. And it looks like those are cut out good. Without, with. If you apply it. And that looks good. So when you put the nut in there, you put the bolt in there and tighten them down, and it clamps it to the shaft. Oh. And so this motor works kind of like this. So if you can get a bolt that's short enough, it'll actually fit down inside of here. How I use it though, I have it up a little bit so that you can use longer bolts. I just add washers to this with the actual bolt there. Because just to show you, I'll make a... Actually, let me do that. Put the cursor here first. Then make a bolt. And this will be an M8. And let's actually do the shank length 20. Thread length 20. Actually, let's make the shank 40. And the bolt length, let's do 30. That looks pretty close to the bolts I'm using. It's not exact, but I don't know what they are exactly. It's something I bought at the store that I thought would work. And so if you look, it's off by a little bit. So if we rotate by 30 degrees, it'll be right on there. And so it looks like I made that hole almost too precise. You probably would want to make it a little bit larger. Size, Shift Z, because we don't want it to go bigger on the Z axis, just the X and the Y. Oh, we'll do that. Okay, so that looks better there. But you can make it bigger, and you can make the inside, you can take out whatever parts you want. You might put circles and do all kinds of fancy stuff with the Boolean if you want to take out cones or something like this. Let's go like that. This is just a quick example. You can do whatever you want. Put your logo in there for the gear. Do something else, something different. But you can put whatever you want and just make the inside of the space. Because you really don't want to print. You can print the whole filament full thing, but it's just kind of a waste of filament because you can take out a lot of stuff in there just to save on filament. But that's the basic idea of the gears, and then you can do the skewed stuff like that. And actually, I think I might have that here. Yeah, my 3D printer I'm working on, I made a 2-to-1 ratio gears with my Inventomark logo inside of them. That one. This one I kind of just did it that way, but all I did for these is I made the regular gear, made the skewness one way, going the other way, and then you have to kind of line them up with the opposite. Just make one half of the gear and then duplicate it and move it down exactly, mirror it, and then remove the doubles from it, and it'll line up after you join it together, and you basically get the tractor wheel type gear, the chevron type. That's basically the basics on gears. But these are both, they're all different size gears, but they're both 2-to-1 because this is gonna be my X and Y axis. And for the extruder, I made a little bit chunkier gears. These ones I haven't really finished yet. I just have the basic design idea down on them. But that's what they're gonna look like. It's gonna be a dual extruder. But I have pretty much the entire design finally done. It's not too fancy in some spots, but for the most part, looks like it's gonna work. Oh, that's my banana for scale. Anyway, that's pretty much it for today. Thanks for watching. Take care.